Welcome to the first live stream of the summer break. I am now on summer break. I know some people still have a few days left of school, but in this live stream I'm going to be working or beginning to work through the AS level content. So I'm going to be working through this textbook here, Edexcel AS and A-level mathematics, pure mathematics, year 1 AS level. So if you want to join in and do some revision with me, I'd love your company. So just having a look at this textbook here, we'll have a look at the contents. It starts off, as you can see, with GCSE level stuff. So this is stuff you've done already: algebraic expressions, index laws, expanding brackets, factorising. All of this stuff is revision, right? So we're going to hopefully work through the first couple of chapters fairly quickly and then get into some of the newer content. So hopefully in this live stream I will get through all of chapter 1, but we'll see how we go. That's the goal anyway. So we're going to be starting with chapter 1, algebraic expressions. Hello Goofboo. So yeah, that's the plan, and I hope to be doing these daily and to get through all of this content over the summer, but we'll see how we go. So, and hopefully there's ways of you, because we're live streaming, there's ways for you to join in as well, but let's see. Okay, algebraic expressions. It says, after completing this chapter, you should be able to multiply and divide integer powers, expand single term over brackets and collect like terms, expand the product of 2 or 3 expressions, factorize linear, quadratic, and simple cubic expressions. That's actually something new, I believe. I don't think you have to factorize cubic expressions in GCSEs. Know and use the law of indices, simplify and use the rules of surds, and rationalize denominators. Most of that, besides this one, I believe is all GCSE revision. Daniel, welcome. Hello, I'm in year 10 and wondering the best way to revise for maths. The best way to revise for maths. Okay, so let's talk about revising for maths just before we get into some of these. Depends what works for you. Like, do you work well independently or in a group? If you work well with others, then maybe it might be helpful for you to get together like a revision group or a group of friends that you can maybe like help each other revise. Maybe you could get together and do some work, or if you work better independently, then just set some time aside for yourself each evening and like consistently get some homework done on mathematics. Or do you, and also do you work well, like are you I know this is a bit of a cliche, but are you like a visual learner, or do you like videos a good way for you to revise, or do you prefer textbooks? Think about those things. So maybe YouTube is a really good resource for you, or if you are better at revising from textbooks, then make sure you get a textbook from school, and that can help you out. So there's a couple of tips. Not using, hello. Math Alab Dali, the best way to revise maths is to do maths. Good point. Okay. Alright, so let's get started on chapter 1 then. It has some revision notes here. I'm not going to go through everything in this textbook. I'm going to be skipping some stuff. There's obviously a lot of repetition in textbooks, so I'm not going to be doing every single question, but I will be doing the question, well, a few from each exercise and the questions that I think are interesting. So here's a note. Computer scientists use indices to describe very large numbers. A quantum computer with 1000 qubits, quantum bits, can consider 2 to the 1000 values simultaneously. This is greater than the number of particles in the observable universe. Interesting. talking about quantum computers there. It gets me thinking actually, I wonder what the future is going to be like once we actually have workable quantum computers. That will be really interesting to see what we can achieve with those. The power of quantum computers is exponentially much more powerful than the computers we use today. It's really hard to imagine what we'll be doing with computers in the future. But anyways, so it has a couple of exercises here that you should know how to do from GCSEs. Things like simplify 4m squared n plus 5m n squared, take 2m squared n plus m n squared, take 3m n squared. So that's just trying to help you recognize which are the like terms here. So 4m squared n, that's a like term with negative 2m squared n. So can you recognize the like terms there? And this one here is index laws, basically 2 to the power 5 multiplied by 2 to the power 3, the same base, you add the powers. So this will be 2 to the power 8. As I said, I'm not going to go through everything, so let's get stuck into the work here. So the first section of this AS level textbook is index laws. As I said, as I've been saying, this is all GCSE revision, but this is where we're going to get started. And hopefully we can get through this chapter fairly quickly. So, the notes here, a to the power m multiplied by a to the power n equals a to the power m plus n. A to the power m divided by a to the power n equals a to the power m take n. A to the power m all to the power n equals a m multiplied by n. And ab to the power n equals an to the power a to the power n b to the power n. Okay, and let's start off with a couple of these ones. Let's do 2 of these. Let's do A, actually let's do E and F. Okay, so starting off then, nice and easy. We've got A cubed squared multiplied by 2A squared. What are we going to do with this? Well, remember your index laws. We've got A cubed squared. We multiply those powers. So this is going to be A to the power 6. And then this one is 2A squared. And then basically you are, well, you've got 1a to the power 6 multiplied by 2a squared. You multiply the numbers, so 1 times 2 is 2. And then the same base with powers of 6 and 2, you add those powers. So this will be 2a to the power 8. And a few other people with tips come in. Mr. AM Gaming, do as many exam questions as possible. Good tip. What is the difference between, and then Harsh Welcome says, what is the difference between AS and A level? So AS is just the first year of A level. That's basically it. So you do AS level and then you do A level, or you can think about it as year 1 and year 2. Hello Noor, welcome. Okay, part F. We've got 3x squared to the power of 3 divided by x to the power of 4. Again, using your index laws, you need to cube everything in these brackets. 3 cubed is 9. X squared to the power of 3, you multiply those powers, so 2 times 3 is 6. Divided by x to the power of 4. Actually, we should write this as 9x to the power of 6 over x to the power of 4. Because usually with algebraic expressions we don't write the division sign. So then, well, if you need to check your index laws, go back to your notes. Otherwise, hopefully remember that when you've got the same base and you're dividing those, you subtract the power. So 6 take 4. And final answer here would be 9x squared. Okay. Let's see. Okay, so the second, oh, these are examples. Oh, why am I doing the examples? I'm not sure. But anyways, oh, lucky I checked. Lucky I was doing the examples. I did 3 cubed is 9. 3 cubed is 27, of course. Always bound to make those little mistakes. So 27x squared. Yeah, I'm not sure I was doing the examples. These are all examples. Okay, let's get into the exercise. Exercise 1A. And it's asking us to simplify these expressions. I'm just going to do this column here. Or maybe the last two rows. No, this column. Let's do this column. So starting off with C, k to the power 3 over k to the power 2. We subtract the powers. This will be k to the power 1, or just k. F, we've got y to the power 2 to the power 5. We multiply the powers, y to the power 10. I, we have 2a cubed all squared divided by 2a cubed. Hopefully this is revision for you. Hopefully this isn't really anything new for anybody. And as we get through this work, we'll get into some more interesting stuff. But this first one here, 2a cubed squared, we square everything in the brackets. 2 squared is 4. A cubed squared is a to the power 6 divided by 2a cubed. Then we have 4 divided by 2, which is 2. A to the power 6 divided by a cubed is a to the power 3. Okay, let's continue. L, 21a cubed b to the power 7 over 7a b to the power 4. And by the way, if you like this idea, let me know. If you have other ideas for these live streams, let me know as well. We don't have to be going through AS content the whole time, but we'll see how we go. If there are other ideas that people want to go through, if there are other things people want to do, we can do those as well. So this one, 21 divided by 7 is 3. A cubed divided by a is a squared. B to the power 7 over b to the power 4 is b cubed. Okay, O, 7a to the power 4 multiplied by 3a to the power 4 squared, all squared. Well, let's leave that first term as is. And then we have to square everything in these brackets. 3 squared is 9, a to the power 4 squared is a to the power 8. And then we have 7 multiplied by 9 is 63. A to the power 4 multiplied by a to the power 8 is a to the power 12. And I will go through and check all of my work right at the end. So I'll go into the answers and make sure I'm getting these all correct or picking up any mistakes. So I'll do that right at the end. Okay, so that was exercise 1A. As I said, I'm not going to do every single one. It just gets a bit repetitive. Okay, we're on to part 2 here. That was part 1 of exercise 1A. And if you want to do this with me, if you want to do the work yourself, you can go ahead and do some of these, and I'll try to zoom in a little bit as well. Let's see. Nope. Let's see if 200 is better. There we go. So you can maybe see it a bit better. So Harsh says, is descriptive statistics classical inference proportions and classical inference mean in A-level maths? I don't think so. Headshot Spiral, please go through all main AS content as I'm going to start A-levels in September. Okay, great. So you like this idea as well. That's good. Have you not started learning A-level math content? James, welcome. Could you do A-level further maths too at some point? We could do some of that. Sure. I could try. Sabindra, welcome. Okay, so for those of you just joining, we are going through, we're beginning the AS level content. And this is the start of it. So this is basically a revision of GCSE content. And we're up to this second exercise, expand and simplify if possible. And again, I'll probably just do this column because I don't want to do all of them. It just gets a bit repetitive. But starting off with C then, we've got negative 3y multiplied by 4 take 3y. So expanding brackets, hopefully you remember how to do this. Just multiply the term in the front of the brackets with everything inside the brackets. So negative 3y multiplied by 4 is negative 12y. Negative 3y multiplied by negative 3y is positive 9y squared. Okay, f negative 5x multiplied by 4x plus 1. This is negative 20x squared, take 5x. I, negative 2x multiplied by 5x, take 4. This is negative 10x squared plus 8x. I have the statistics and mechanics books as well, so I could do some sessions on statistics and mechanics, AS or A level, whichever you prefer. Maybe tomorrow we could do statistics, and the next day we could do mechanics, or however you think, or however people would like to see it. Okay, working through these, and hopefully you're getting something out of this, possibly just an idea of how to revise. So for this one, I'm distributing that negative to both terms in the brackets, negative 3x and then plus 2, and then we need to simplify. So 5x take 3x is 2x, negative 6 plus 2 is negative 4. Onto Q, and let me know if you can see okay. If it's too small, if the writing's too small, maybe I could do something about that in the future. Q, I've got negative 2y squared, 5 takes 7y plus 3y squared. Okay, we need to expand this out. Expand the term to every term inside the brackets. Negative 2y squared multiplied by 5 is negative 10y squared. Negative 2y squared multiplied by negative 7 is positive 14y cubed. And then the last one is negative 6y to the power 4. So y squared times y squared is y to the power 4. This GCSE stuff, why would they make you do this? Good point. Good point. We'll get into some more interesting stuff soon. I think they start off with the revision because usually you're coming back from summer and, you know, I guess they're just trying to get your mind back into mathematics. Whoa, what happened there? Okay, I think it just cut out for a second, but hopefully everything's fine now. But yeah, I think they're just trying to get your mind back into the mathematics, and they just start off with some revision content. I probably would not start this way. If I was starting the year off, I would start off with something a bit more interesting, but and I could have done the live stream starting with something more interesting, but I thought this was just working through a textbook is the easiest, most straightforward way to do it. So Q, we still have to, we don't have to simplify anything here because we don't have like terms. So we're on to S. We have 5x take 3, 4 take 2x plus 6. We need to expand these brackets, so we'll have 5x take 12 plus 6x plus 6. And then simplifying further, 5x plus 6x is 11x, negative 12 plus 6 is negative 6. Okay, and the last one in this section, 3x squared multiplied by 2x plus 1, take 5x squared multiplied by 3x, take 4. Okay, expanding both of these sets of brackets. Welcome, Jake. Jake says it's all clear for me. That's good. Good to hear. Okay, expanding this one, 6x cubed plus 3x squared. And then 5x squared multiplied by 3x is negative 15x cubed plus 20x squared. And then we have some like terms here we can simplify. So 6x cubed takes 15x cubed is negative 9x cubed. And then 20x squared plus 3x squared is 23x squared. Okay. Any other interesting problems in there? I think they all look pretty similar, so that's where I'm going to leave it for exercise 2. On to exercise 3. And here I might just have a little break, and you can work through. I might do every second one here. I'll do A, C, and E. So if you want to do A, C, and E, give those a go, and then I'll do those in a couple of minutes. So Harsh says, I know all the interesting stuff. I think our students would really enjoy chapters from binomial expansion. Okay, binomial expansion, that's coming up. Binomial expansion is coming up in, where was it? Oh, that's in chapter 8. So it's not till chapter 8. So that will probably be next week. Oops, sorry about that. So the school should always show you the proofs of the formulas. True. Missed Bolt, do you cover further maths content? I have not done any further maths content on my channel yet, but maybe one day. No promises though. Okay, so 3a, we have 6x to the power 4 plus 10x to the power 6 over 2x. To simplify these, I guess we have to factorize the top line. So common factors of those two terms in the numerator would be 2x to the power 4, and then what would we have left over? 3 plus 5x to the power 2 over 2x, and then we cancel. So let me just check. Do they call it cancelling? Oh, they just call it dividing. That's weird. They split it up like that. Okay. Okay, so this is possibly an easier method than I was doing. So I was factorizing the top line, then simplifying, but you can just split the fraction up into two terms, and then do the simplifying. Well, yeah, I guess that makes sense. I don't know, I've just always done it where I factorize and then simplify. But there you go. Okay, so we'll do that for the next two. We'll do that method. So then, actually, yeah, that's going to be easier, isn't it, for this one? Rather than factorizing it, just split it up into two fractions. There you go. You learn something new every day. And then simplify. So then divide by 2, we get 3x cubed plus 10 divided by 2 is 5, x to the power 6 divided by x is x to the power 5. There you go. Okay, so that's much easier. Rather than factorizing, just split it up into two fractions and then simplify. Jake, what chapters are you doing today? I'm going to attempt to get through chapter 1. At this rate, I'm not sure I can, but we'll see how we go. Can you do A2 mechanics content, please? Hopefully we'll get on to A2 mechanics. I'm starting with the AS content because, well, I figure that's the most useful to most people. But if people are asking more for A2 content, then we can get onto that. Okay, so next one, C. 2x to the power 4, take 4x squared over 4x, split them up. 2x to the power 4 over 4x, take 4x squared over 4x is, well, the 2 we cancel with the 4, we'd still have 2 in the numerator, so we'd have a half x to the power 3, take x, just x, so the 4's cancel and x squared cancels with x, so we just got 1x left. And then the last one is e, 7x to the power 7, take, plus 5x squared on 5x. Split them up. I don't know why I've never done it this way. This is much easier. 7x to the power 7 over 5x plus 5x squared on 5x. And then simplifying, well, 7 and 5, we can't really do much with that. I would leave that as a fraction. X to the power 7 over x is x to the power 6. 5x squared over 5x, we're just left with x again. Okay. So that is, what was that section called? That was called index laws. So we've done section 1, index laws. We're on to expanding brackets. Okay. Section 1.2, expanding brackets. And it tells you how to expand brackets. You multiply everything in the first bracket by everything in the second bracket. So to find the product of two expressions, you multiply each term in one expression by each term in the other expression. Again, this is GCSE level stuff. You should have learned how to do this already. Hello, Nishat. Okay. So it has some examples here of quadratics and binomial multiplied by a trinomial. Okay, all fairly standard stuff. Here, again, we have some more examples. So they have 3 double brackets, and they suggest multiplying the first 2 brackets and then multiplying everything. Or you can multiply the first set of brackets and then write it like this, so you have each term multiplied by the second brackets. That's another way of doing it. Okay, on to exercise 1b. 1b. Exercise 1, expanding brackets. Let's just do the last column as I've been doing so far. So this one here I'm going to work through. As I have said a couple of times, I'm not going to do every single exercise because it just gets way too repetitive. Okay. Yeah, welcome. Mubashir, welcome. Okay, x take 2 all squared we can write as x take 2 multiplied by x take 2. This is x squared take 4x plus 4. So multiply. Hopefully you know how to expand double brackets. The method that I usually use is FOIL. So this stands for first terms, outer terms, inner terms, and last terms. Okay. F 2x take 4y multiplied by 3x plus y. So what I'm saying here is we're multiplying the first terms, 2x multiplied by 3x, that's 6x squared. The outer terms, 2x multiplied by y is 2xy. The inner terms, negative 4y multiplied by 3x is negative 12xy. And then the last terms is negative 4y times y is negative 4y squared. And then we need to simplify, combine those middle terms, we'll have 6x squared, positive 2x take 12x is negative 10. xy take 4y squared. This is AS, so year 1 of A levels. Year 12, yes, year 12. Okay, and this is chapter 1. I'm going to be attempting to work through this textbook over the summer, so all of the year 1 content, and obviously chapter 1 is revision of GCSE stuff, and it starts off with this algebraic expressions chapter, And so this live stream might not be too exciting, but hopefully we get into more interesting stuff as we go along. So onto I, we've got 2x plus 8y multiplied by 2x plus 3. As always, expanding double brackets. First out is in as last, 4x squared plus 6x plus, 6, oh, it is just 6x because it's just 3 there, and x here. And then in the middle we've got 16xy and then 24y. So actually here we cannot combine the middle terms because they are not like terms. And that's all we can do with that one. Okay, on to L. X take 4y multiplied by 2x plus y plus 5. Here we have double brackets multiplied by an expression with 3 terms. We multiply everything in the first set of brackets with everything in the second set of brackets. So x times 2x, 2x squared. X times y is plus xy. X times 5 is plus 5x. Negative 4y times 2x is negative 8xy. Negative 4y times y is negative 4y squared. And multiplied by 5 is negative 20y. Okay, then once you've done this, check for like terms. So there's no x squareds, there's an xy over here, so we are going to have to simplify. We've got xy take 8xy, that's negative 7xy, and there are no other like terms, so that's the only one we had to simplify there. So then we've got plus 5x take 4y squared take 20y. And we're done, and I will check all of these at the end just to make sure I haven't missed anything. And if you notice any mistakes, please let me know. I'm bound to make some mistakes as we go along. Okay. Next one, 4 take y multiplied by 4y take x plus 3. Again, multiply everything in the first brackets by everything in the second brackets. 4 multiplied by 4y is 16y. 4 multiplied by negative x, negative 4x. 4 times 3 is plus 12. Negative y multiplied by 4y, negative 4y squared. And then we have a plus xy and a negative 3y. And then check to see if you can simplify. I see a 16y and a 3y, so they are like terms. 16y take 3y is 13y, and that I believe is everything we can simplify. So then we've got a plus xy take 4x take 4y squared plus 12. Okay, and we're done. And the last part of this exercise that I'm going to do is 4y take x take 2 multiplied by 5 take y. Okay, again, multiplying everything by everything, basically. So 5 times 4y is 20y. 5 times negative x, negative 5x. Then a negative 10. Then we have negative 4y squared, positive xy, and a positive 2y. And then check to see if there are any like terms. We have a 2y and a 20y, so that will be 22y. And then that's all that we can simplify. So plus xy, take 5x, take 4y squared, take 10. Okay, we're done with that one. Expanding brackets. Hopefully there's nothing too new in there for you. On to exercise 2. Let's see. Okay, so we have a couple of different types of problems in here. We'll see how we go. So firstly, 3x take 3 multiplied by x take 3. Well, I would expand the brackets and then multiply everything by 3. So this would be 3 times x squared take 6x plus 9 is 3x squared take 18x plus 27. And we're done. For part C, part F, we've got y multiplied by x, take 5 multiplied by x plus 1. Again, expand the brackets. We've got x squared, x take 5, that would be negative 4x take 5. And then multiply everything by y, so this would be x squared y take 4xy take 5y. Okay. 1, 2, 3, 4, 5, 6. So I'm going to do another 6 exercises in here. I'll just zoom that in a little bit more. Oh, there we go. So I'm going to do I, L, O, R, U, and X. Just take a quick break. If you want to work through those before me, then feel free to have a go, and I'll be back to complete those in a minute. Okay, on to part I. If you had a go, hopefully it's making sense so far. So I is x multiplied by 2x plus y multiplied by 5x take 2. Expand the brackets. I just want to check something actually. Is this how they're suggesting to do it? Before I had a revelation as to how to simplify algebraic expressions, so maybe they have something new for me here. Oh, they're suggesting expand the term with one set of brackets and then expand the brackets. Interesting. So let's give that a try. Let's give that method a try. So rather than expanding the brackets and then multiplying everything by x, let's multiply the first set of brackets by x and then expand. It really doesn't make much of a difference, I guess, but there you go. So 2x squared multiplied by 5x is 10x cubed. 2x squared multiplied by negative 2 is negative 4x squared. Multiply the inner terms here, we'll have 5x squared y, and then the last term's negative 2xy. And I don't see any like terms there, so that would be the final answer. How long will I be live streaming for? Well, I'm up to exercise 1b, and there are 4 more to go. So we'll see if we can get these done, but probably another hour or so, I'd say. Okay. L y multiplied by 3x plus 2y take 3 multiplied by 2x plus 1. Expand the y first, so we'll have 3xy plus 2y squared take 3y multiplied by 2x plus 1, and then expand the bracket, so multiply everything by everything. I do this in reverse, so I do the bracket multiplied by these. So 2x multiplied by 3x, y is 2x squared, 6x squared y. 2x multiplied by 2y squared is 4x y squared. And then 2x multiplied by negative 3y is negative 6xy. And then multiply everything by 1, we just have those same terms. So 3xy, 2y squared, and negative 3y. And can we simplify anything here? yes, we can simplify these two terms. And that's it, I believe. So 6x squared y plus 4xy squared. Negative 6xy plus 3 is negative 3xy plus 2y squared take 3y. Are there any like terms there? I don't see any, so that's my final answer there. Whew, these take a while, even though they're kind of, you know, it's just like following a method, but it just takes a long time. Okay, 3x multiplied by x take, x take 2y multiplied by 2x plus 3y plus 5. Expand that term with those first brackets. We'll have 3x squared take 6xy. And then we need to expand everything. Yep, doing some work today. Trying to get through a lot of kind of repetitive exercises. Trying to grind through this initial chapter of this book in order to get into some more interesting stuff. Okay, then multiply by everything. So 3x squared multiplied by 2x is 6x cubed. 3x squared multiplied by 3y is 9x squared y. And then we have a 15x squared. And then, I'm going to run out of room here. Negative 2x squared y. Take 18x y squared. Oh no, I've run out of room. And then we have a negative 30xy on the end. Are there any like terms in here? Yes, we have this 9x squared y and this negative 12x squared y. And that's it. So simplifying those, we'll have 6x cubed. 9 take 12 is negative 3x squared y plus 15x squared take 18x y squared take 30xy. Whew, okay. Okay, let's do three more of these. I might run out of notebook actually. This time we've got 3 sets of double brackets. Okay. And this is not something we commonly do in GCSE, so practicing this actually would be a useful thing to do starting your A levels. So to expand 3 double brackets, firstly expand the first 2. So this would be x squared take x plus 3x. Actually, we can do that in one step. So negative x plus 3x is plus 2x. And then negative 3 on the end. Multiplied by x, take 5. And then the way they suggest to do it is to write it like this. So multiplying these terms by these double brackets, so you can write it as x squared multiplied by x take 5 plus 2x multiplied by x take 5 take 3 multiplied by x take 5. And this kind of separates it out to make the next step a bit easier. So this would be x squared take 5x squared, x cubed take 5x squared, sorry, plus 2x squared take 10x, and then negative 3x plus 15. And then simplifying, there are no other x cubed terms, so leave as is. Negative 5 plus 2 is negative 3x squared. And then negative 10 take 3 is negative 13x plus 15. And we're done. 2 more to go of these. Okay, 2x plus 3 multiplied by 3x plus take 1 multiplied by x plus 2. Again, let's expand the first sets of double brackets. So this would be 6x squared. Take 2x plus 9. Okay, let's just do this in 2 steps. Take 3 multiplied by x plus 2, and then this will be 6x squared plus 7x take 3 multiplied by x plus 2, and then expanding this, so each term is multiplied by x plus 2 plus 7x multiplied by x plus 2 take 3 multiplied by x plus 2, and then expanding these, this gets lengthy. 12x squared plus 7x times x is 7x squared plus 14x take 3x take 6. Then simplifying, we have 6x cubed, 12 plus 7 is 19, x squared plus 11x takes 6, and we have one more to go. We have x. 2x take 3y cubed. There must be a shortcut to that, but I forget what it is. Okay. Well, I guess you could just start off by writing it like this. 2x take 3y multiplied by 2x take 3y. If in doubt, learn the Maclaurin series. And, well, let's do it this way and then maybe we'll recognize something. Yes, and you can use binomial expansion for sure. So expanding the first two sets of brackets, 4x squared, take 6xy, take 6xy, take 12xy plus 9y squared, multiplied by 2x, take 3y, and then expanding this set of double brackets with each term, we'll have 4x squared multiplied by 2x, take 3y, take 12xy multiplied by 2x, take 3y. Oh, this is just a longer way of doing it. Okay, I see. 9y squared multiplied by 2x, take 3y equals 8x cubed, take 12x squared y, x squared y, take 24x squared y, take 36xy squared plus 18xy squared, take 27y cubed, and then simplify. 8x cubed take 36x squared y, take I feel like I made a mistake here. Maybe not. So what was I up to? 36xy squared plus 18. The difference there is 18, of course. So this is negative 18xy squared take 27y cubed. Yeah, I've done something. What have I done wrong here? Yes, plus. That should be a positive 36. But I still feel like I did something wrong. Oh no, because that's 3. Was that the only mistake? Plus instead of subtract? this is correct. So this is fine. Then expanding. Yeah, okay. I guess that's all fine. Yep. Okay, so then this is 36 plus 18. That's what? 56 plus 56. Sorry, 54. Okay. Alright, okay, so that's my final answer there. 8x cubed take 36x squared y plus 54x y squared take 27y cubed. What do we notice about the connection between the first expression and the last one? Well, we cubed 2x, we cubed that. If we square both and multiply, we get 36. If we multiply and then multiply by 9. Okay, so the first terms are those terms cubed, and the middle terms, I'm forgetting the relationship. It's this term squared multiplied by multiplied by something. This number squared, but then it would be a negative. What about 54? That's 3y squared times 6. Anyway, something to think about. Okay. Alright, let's do some problem solving questions. They're usually a bit more interesting. Let's start on a fresh page. Okay, on to question 3, problem solving. The diagram shows a rectangle with a square cut out. The rectangle has length 3x take y plus 4 and width x plus 7. Okay, so let me draw. Oh, they've kind of, yeah, they've labeled the dimensions already for us. So the length is 3x take y plus 4. The width is x plus 7. The square has length x take 2. Find an expanded and simplified expression for the shaded area. Okay, so shaded area questions, you work out the larger shape, you work out the smaller shape, and you subtract them. So basically what we're doing here is the length times the width to get the area. So x plus 7 multiplied by 3x take y plus 4. Let's expand and simplify this. So 3x squared take xy plus 4x plus 21x take 7y plus 28. And then simplify, so 3x squared take xy plus 25x take 7y plus 28 is my simplified expression. And then the area of the square, so I should say this is the area of the rectangle. area of rectangle. Oops. And then the area of the square is x take 2 squared. This is x squared take 4x plus 4. Then we need to subtract those. So we're going to do, going to run out of room. We're going to do 3x squared take xy plus 25x take 7y plus 28 subtract x squared take 4x plus 4. Okay, so 3x squared take x squared is 2x squared. The other like terms are 25x and 4x, so we'd actually add that 4x because they have a negative 4x, so that would be positive. Actually, let's not forget the negative xy. So 25 plus 4 is positive 29x, and then negative 7y, and 28 take 4 is positive 24. Okay, that would be my final answer there. Okay, so there's a little tip. Use the same strategy if the lengths were given as numbers. Okay. Question 4. Problem solving. A cuboid has dimensions x plus 2, 2x take 1, and 2x plus 3. Show that the volume of the cuboid is 4x cubed plus 12x squared plus 5x takes 6. Alright, that's just kind of the same thing we're doing above, but with a bit of context. So, hello Disha. Thanks for dropping in. So, how do we find the volume of a cuboid? Can somebody tell me that? How do you find the volume of a cuboid? The volume of a cuboid is length times width times height, of course. Length times width. Whoa, what happened there? Length times width times height. So you'd multiply exactly Rab Nation. Thank you. You'd multiply those three terms there, and you'd be doing just what we were doing before, multiplying 3 sets of double brackets. And hopefully you'd end up with this: 4x cubed plus 12x squared plus 5x takes 6. I want to jump to this challenge. It says expand and simplify x plus y to the power of 4. So this is the challenge they give us. This would be new content, so we don't really do any of this in GCSEs, any double brackets to the power of 4. But we can approach it the same way we've been doing all of the previous problems, and Disha says that one is easy. Okay, so I would probably write it like this, and then expand these out: x squared plus 2xy plus y squared. You get 2 of these. And then you could expand those sets of brackets. Well, I guess this is an extra level of difficulty because you're multiplying 2 sets of 3 brackets, which is not in any of these ones. So it is, I guess, a challenge in that respect. Question 4. Question 4. So maybe we'll go back to question 4 in a minute. So let's continue with this one here. I the way that I do this is, again, just multiply everything by everything. So the x squared multiplied by everything in these brackets, 2xy by everything here, and you could even write it like this, I guess. You could write it as x squared multiplied by x squared. That's going to take too much time. So let's just do it mentally. So x squared multiplied by everything, we'll have x to the power 4 plus 2x cubed y plus x squared y squared plus 2x cubed y. So now multiplying 2xy by everything plus 4x squared y squared plus 2xy cubed onto the next line, and then we've got to multiply everything by y. So x squared y plus 2x y squared plus y cubed, and then simplify. So x to the power 4 made a mistake. No. Plus x to the power 4 plus 4x cubed y plus 5x squared y squared plus this. No, that's right. Oh, I always make mistakes with these. There's so many terms and so many powers. What was I up to? I was up to x squared y squared, and then 2x cubed y. I've simplified that. So one way to do this is actually cross them out as you go. And then I've got 2x y cubed. There's no other like terms with that one. 2x y cubed plus x squared y plus 2x y squared plus y cubed. I feel like I made a mistake there. But what we could do is, it says here you can use the binomial expansion to expand expressions like x plus y to the power 4 quickly. So should we jump to section 8.3 and have a look at how to do that, at a shortcut as to how to do these ones? What do you think? Yes, the shortcut. Alright, so binomial expansion. Here's the example we probably want to use. So a binomial expression has two terms. Binomial expansion allows you to expand powers of binomial expressions. For example, in the expansion a plus b to the power 5, the term a squared b cubed occurs 5 choose 3 times. Sorry, I was forgetting the correct terminology. Occurs 5 choose 3 times. This is because you need to choose b 3 times and b 3 times from the 5 brackets. You can do this in 5 choose 3 ways. So when the expansion is simplified, the term in a squared b cubed is 5 choose 3 a squared b cubed. And then down here it says work out each coefficient quickly uses the n, choose r, and power functions on your calculator. Okay, so when you have the power of 5, you'd have 5 choose 1 plus 5 choose 2 plus 5 choose 3 plus 5 choose 4. So then another example, 1 plus 2x to the power of 10. You raise the first number to the power of 10, then it's 1 to the power of 9 multiplied by 2x, and 10 choose 1 in the front. And the second term is 1 to the power of 8, 2x squared. Hopefully you can see the pattern there. And then 10 choose 2, plus 10 choose 3, and so on. So if we apply that to this example, we would have, well, x to the power of 4 plus 4 choose 1, x to the power of 3y plus 4 choose 2, x squared y squared plus 4 choose 3, running out of room, x y cubed plus 4 choose 4 is just 1, so then it's just y to the power of 4. Okay, so clearly I've made a mistake here somewhere. Oh, that should be something. Okay, so hopefully that's making a little bit of sense. Here's the formal formula, how that looks, and in practice this is what you would do. To find these 4 choose 1, 4 choose 2, 4 choose 3, as it says, you can use your calculator. I've forgotten where that is on mine. Let's see. There it is. N choose R. Oops. But how do I've forgotten how to do it. Oh, I've got to put the number in. I've got to put 4, and then I have to go to N choose R. Oops. Wrong one. Then I've got to go to N choose R, and then put in 1, I believe, and I get 4. So 4 choose 1 is 4. So remember, I'm looking at this example, x plus y to the power of 4. The first term is x to the power of 4. Then I have 4x cubed y, and then 4 choose 2. So I put 4 in, and then maths. I go to this function. Oops, wrong one again. Then I go to NCR on your. If you have one of those class whiz calculators, you'll also have an NCR button somewhere on your calculator. So put in 4, then press that NCR button, then put 2, and 4 choose 2 is 6. So this is the number of ways of taking 2 objects from 4 things. That's what 4 choose 2 actually means. So I've got 6x squared y squared. How do I, thank you, so Disha says like your calculator, how do you do that? How do I get the calculator, or how do I, what were you referring to there? Rab Nation, do you live stream GCSEs as well as A-level? Yeah. Sometimes I'll stream GCSE stuff. And then 4 choose 3, that's going to be the same as 4 choose 1, but let's just do it anyway. So 4 choose 3 is also 4. So we get plus 4x y cubed, and then plus y to the power 4. Okay, so there's your little shortcut for expanding out brackets. And now let's see if I can spot the mistakes I made in here, because clearly I made some mistakes. I didn't get the correct answers. So where are my mistakes up above? Firstly, I did x squared times x squared, then 2x, oh sorry, I was meant to multiply that one. So 2x cubed y, and then x squared times y squared. Okay, that's fine. Then 2x cubed y, that's fine. Then 2x squared y squared, that's okay. And then 2x y cubed, fine as well. Last one, x squared y is okay. 2x y squared, and then y cubed. Alright, I don't see any mistakes. It must have been with the simplifying. Yes, I think you are allowed to have a graphics calculator in A-levels. I have not seen anything saying you cannot have a graphics calculator. It's just that they're more expensive, so we don't usually suggest you get one. And you don't really need a graphics calculator, so there's not much point spending the money on one, but I'm pretty sure they're allowed. Unless someone can point me to a link saying they are not, but I think they are. I'll try to look up some more information on that to make sure, but yeah, I'm pretty sure. Okay, so I'm still trying to see where I went wrong here. This is 4x x cubed y. Why am I getting 5x squared? That should be 6. I should have another x squared y squared term. Oh, this is x squared y squared. There's my mistake. This should be a y squared. This was x squared. No. What one was this? Oh, that was. Oh, that should be y squared in there. Oh no. I wrote that part wrong. That should be y squared. That changes everything. Then this is y squared, this is y cubed, and this is y to the power 4. And then we would get the correct answer. Okay, found my mistake. Wrath of Anime says, I'm scared for A-levels. Well, you've come to the right place. Hopefully, these live streams will help you out. So what we were just doing was, we started on chapter 1, and we actually found a little shortcut for expanding brackets. So we were looking at this challenge here. We saw we had x plus y to the power 4, and we did it the long way, and then we found a little shortcut here. This is binomial expansion. So we found this little shortcut. We jumped ahead a little bit, and we used binomial expansion to get to the answer much quicker. So rather than doing all of this to get x plus y to the power 4, we just did this. So we did x to the power 4 plus 4 choose 1 x cubed y plus 4 choose 2 x squared y squared plus 4 choose 3 x y cubed plus y to the power 4. That got us to the answer much quicker. And actually I forgot to correct this. So this, I figured out my mistake and eventually got to the correct answer. Okay. Funny Sanju says, can you explain circular measure? No, because I'm not sure what you mean by circular measure. Sorry. Is there another name for that, or I'll have to check that later. By the way, isn't GCSE FM harder than AS level maths? Possibly. Possibly. Okay. Alright, so we're on to factorising. This will be the last section I do here, and then I'll have to end the live stream. Okay. We're on to 1.3, factorizing. You can write expressions as products of their factors. Factorize is the opposite of expanding brackets. Factorizing, I don't like this definition of factorizing. It's always given as a definition, but factorizing is, breaking things into their factors, right? Like 24 is 4 times 6, that's factorizing. You don't have to think of it as the opposite of expanding brackets. But I guess it is a good example. I haven't really started revision for year 12, but I'll probably start at least maths revision soon. Cool. Well, we're just looking, so just in case anyone's just joined, I am going through this textbook here. So it's Pure Mathematics 1, Year 1 AS level. So I'll be working through this in live streams, as well as other things that people suggest. And I've been working through this chapter. So we've done index laws, expanding brackets, and factorizing. You'll notice this is revision of GCSE content. And that's how your A-levels usually start off. You usually start with revision, or depends on your teacher really. Your teacher might decide to start on something a bit more exciting, but often they will start with some revision, or you will do some revision at some point in your A-levels. Yeah, again, depends on your teacher. They might start you off a little bit easier on some revision stuff, or they might get into something a bit more challenging. And it depends on your class as well. Maybe your class would like to start on something challenging, or maybe your class would like to ease into the year with some revision content. But this is how this textbook starts off, at least. So section 3 of chapter 1 is factorizing. Nothing new here. You should be able to factorize expressions like this, and they give some examples. So 3x plus 9 factorizes to 3 multiplied by x plus 3. Then you can have more complicated ones like 3x squared take 9xy. The common factor there is 3x, and then you are left with x take 3y in the brackets. Also, you should know how to factorize quadratics. So a quadratic expression has the form ax squared plus bx plus c. To factorize a quadratic expression, find two factors of ac that add up to b. Okay, rewrite the b term as the sum of these two factors, factorize each pair of terms, take out the common factor. Okay. And then an expression in the form x squared take y squared is called the difference of two squares. That's an important note as well. Okay, so they have some examples of factorizing quadratics. Good stuff. And then some examples of factorizing the difference of two, oh no, these are just cubics, factorizing cubics. Okay, let's practice a few factorizing exercises. Won't spend too long on this, but exercise 1C, I'm going to work through this column here. Zoom in a little bit. And, oops, where have I gone? Sorry about this. Wrong page. Okay, there we go. I'm going to work through these questions here. If you want to give those a go, I'm going to take a quick break and then come back and finish those off in a minute. Okay, hopefully you had a go at some of those, or maybe you're just like, maybe you're just watching, or maybe you've just tuned in, saw the live link and pressed on it and don't feel like doing much mathematics revision. Either way, maybe at some point I can encourage you to do some of these questions. Anyways, on to these questions here. We're factorizing. So C is 20x plus 15. Common factor there is 5. The highest common factor, I should say. Then we're left with 4x plus 3 in the brackets. F, 6x squared take 18x. The highest common factor there is 6x. And then we're left with x take 3. I, 3x squared take x. The highest common factor is x. Then we're left with 3x take 1 in the brackets. L, 35x squared take 28x. The highest common factor there is 7x. And then we're left with 5x take 4 in the brackets. O, 4x squared plus 12x. The highest common factor there is 4x, and then we're left with x plus 3. R, 6ab take 2ab squared. Highest common factor there is 2ab, and then we have 3 take b in the brackets. Yes, that should be fine. And then U, 15y take 20yz squared. Highest common factor 5y. Then we're left with 3 take 4z squared. And the last one I'm going through is x, 12y squared take 4yx. Highest common factor is 4y. And in the brackets we have 3y take x. That's a bracket. Okay, so that's factorizing binomial expressions. Not too difficult. On to exercise 2, factorizing quadratics. And okay, let's finish off these ones and then that will be the end of the live stream. Okay, so exercise 2. Exercise 2, part C, x squared plus 11x plus 24. We want to factorize this. Look for factors of 24 that make 11. So factors of 24 are 8 and 3, and they will add to 11. So I'll just jump straight to that. Whoops. X plus 3. So x plus 8 multiplied by x plus 3, that would expand to x squared plus 11x plus 24. Part F, x squared take 8x plus 12. Looking for factors of 12 that make negative 8. 6 and 2 make 8. So negative 6 and negative 2 would make negative 8 and positive 12. I, x squared take 3x take 10. Factors of 10 that make 3, 5 and 2. What did I say? 5 and 2. So then we need a negative 5 and a positive 2 to make negative 3 and negative 10. L, 3x squared plus 10x take 8. Factors of 8 and 3 that make 10. We could do, what could we use? We could use 4 and 2 and then 3. So if we have 3x and we multiply that by 2, and then we have a 4 there. But we need it to be positive 10 and negative 8. That's not going to work, so we could try something else. It has to be 3 and 1, of course. They're the only factors of 3. Other factors of 8, 8 and 1. Oh, we could do a positive 12 and then a negative 2. That would give us negative 8 and positive 10. Hello Apollo, Ape, welcome. So this would expand out to 3x squared plus 10x take 8. Alright, let's do n because it looks like n is slightly different to the other ones. So n, we have 6x squared take 8x take 8, and it says take 2 out as a common factor first before factorizing. So if we take 2 out, we'd have 3x squared take 4x take 4, and then we need to factorize this. Factors of 4 and 3 that make negative 4. So factors of 4 are 4 and 1, or 2 and 2. I think I'll go with 2 and 2. Hopefully that works. So then we could have a negative 6 and a positive 2. That would make negative 4 and a negative 4 on the end as well. Okay. Then let's do p as well. P is 2x to the power 4 plus 14x squared plus 24. And we need to factorize this as we would a quadratic. And it says, here's a hint, let y equals x squared. So let y equal x squared. And then if we substitute that in, we would have 2y squared plus 14y plus 24. Then it becomes a quadratic. So using a little trick there in order to change this into a something more familiar. Quadratic expressions, yes. Quadratic expressions, starting off with some GCSE revision. Okay, now looking for factors of 24 and 2 that make 14. So 8 and 3 are factors of 24. So, well, we need to use 2 and 1 because they're the only factors of 2. Whoops. So 2y and y will be my first terms. And then I could have 8 and 3. And if I multiply the 2 by 3, that makes 6. 6 plus 8 is 14. So then if I expand this out, I get 2y squared plus 6y plus 8y, which is 14y plus 24. And then we need to substitute the x squared back in. So we would have 2x squared plus 8 multiplied by x squared plus 3. And we are done. Couple more. Let's do u and x as well. So 36x squared take 4. You could write this as the difference of 2 squares, so this could be written as 6x all squared take 2 squared. And then remember, with difference of 2 squares, you can write it as the first term plus the second term multiplied by the first term take the second term. Okay. Last one of this exercise. Factors of 9 and 15 that make 42. Let's think. Well, I feel like we're going to have to use 15 and 1 to get 42. So let's try that. So if we do, so 15 times 3 is 45. Take 3 is 42. So we could do a positive 3 and a negative 3, and that would give us 15x squared plus 42 take 9. Okay, on to exercise 3. Oops, what's going on there? Factorize completely. I believe for these we're just taking out the common factors. So for C, x cubed take 5x. We have x as a common factor. Is there anything else they wanted us to do with that? No. Oh, and then some of these we might have to do something with. So C, there's nothing else we can do with that expression. F, x cubed plus 11x squared plus 30x. We have x as a common factor, then we have x squared plus 11x plus 30. Then we have a quadratic that we can probably factorize. So let's see. Factors of 30 that make 11. 15 and 2, no, that doesn't work. 3 and 10 doesn't work. Maybe we can't factorize. Abdullah, hi, so very useful. I'm finding this great. Thank you. So can we factorize x squared plus 11x plus 30? I don't think so. So what are the factors of 30? 1 times 30. 2 times 15. 3 times 10. 4 doesn't... Oh, 6 and 5, of course. 6 and 5. 6 and 5 make 11. So we've got x plus 6 and x plus 5. Yes, you can factorize, says Abdullah. Of course you can. Okay, next one. 2x cubed, take 5x squared, take 3x. Common factor of x, let's take that out first. 2x squared, take 5x, take 3. And then can we factorize this quadratic? Factors of 3 and 2 that make 5, well that would be 3 and 2. So, oh, but then we've got 1 left over. Oh, 6 and 1 make 5, so we could do 2x and x, and then multiply that 2 by 3. That would be a negative, and then plus 1, we get negative 5x and a negative 3. Negative 3 multiplied by positive 1 is negative 3. Last one in this exercise, 3x cubed plus 27x squared plus 60x. Common factor there of 3x. Then we have x squared plus 9x plus 20. Can we factorize that quadratic? Factors of 20, 10 and 2, 5 and 4 make 9, so I'll go with 5 and 4. Okay. Alright, so there we go with factorizing some cubics. First we took out the common factor and then we factorized the quadratic. Alright, here we have x factorized completely, x to the power 4 take y to the power 4. Let's have a go at this one. X to the power 4 take y to the power 4. What do you think we can do with this one? Gives you a little hint here. You can write x to the power 4 as x squared all squared. So that's where we can start. X squared squared take y squared squared. Difference of two squares, exactly. And then when you have the difference of two squares, you can write this as the first term plus the second term, and then the first term take the second term. And you'll notice that expands out to this. X to the power 4 take y to the power 4. And actually, you could even factorize this further. We can't do anything with this x squared plus y squared, but we also have the difference of squares here too. So we could do x plus y x take y to factorize it completely. Okay. And the last one is this E stands for an exam style question. So this is something you might get on an exam. Factorize completely 6x cubed plus 7x squared take 5x. Okay, so let's take out the common factor of x. 6x squared plus 7x take 5. And then let's try to factorize that quadratic. So factors of 5 and 6, that makes 7. Well, the only factors of 5 are 5 and 1. What can we multiply by 5? So we could do 10 and 3, that would make 7. So we could do 2x. Oops. That needs to be a 2 here, so that needs to be a 3. And then 2x. So 3x. That needs to be a negative 1. So negative 3x plus 10x is going to give you positive 7x. Okay. A-level, will there be an A-level live stream? So do you mean year 2 stuff? Yeah, we could do that at some point. So I was thinking tomorrow we could do some, well, it depends. Well, let's see. Whoever's in the chat will decide for me. Tomorrow is either AS level statistics or A level pure maths. So those of you still in the live stream, let me know. And if I get one person saying one thing, we'll do that. So tomorrow is either AS level statistics or A level pure maths. Let me know which one you would prefer. A level pure. Okay, if nobody else votes, then that wins. Okay, looks like A level pure tomorrow. Any particular topics? Okay. Well, we can make a start on some A-level pure mathematics. Hitsu says chapter 10. I'm not sure which, what topic that refers to. Proof. We could talk about proof. Personally, I think proof is much more interesting in the context of other topics. But yeah, you can definitely talk about proof just by itself. Okay, so I'm going to finish this with this challenge. I need to write this quartic as the product of 4 linear factors. So the first thing I would start with here is to let y equal x squared. So then this equals 4y squared take 13y plus 9. Numerical methods. Ah, okay. Alright. So maybe tomorrow can be proof and numerical methods. Okay, so then I have this quadratic that I need to factorize. factors of 9 and 4 that make 13. We could do what could we do? We could do 4 and 3 would be 12. So it's either 4 and 1 or 2 and 2. Oh, it's going to be 9 and 1 and 4 and 1, isn't it? So 4y and y. And then we multiply that by 1, and then we have the 9 in here. So we need a negative, so they'll both be negatives. That gives me 4y squared take 13y plus 9. And then replace that x squared. So we have 4x squared take 9. Let's just write it like this first. And then let's write this as the difference of two squares. So 4x squared can be written as 2x all squared, take 3 squared, 9 is 3 squared, and then x squared take 1 squared. You don't have to write the 1 squared, but it just helps with the explanation, I guess. So then we have two sets of differences of two squares. And we know how to deal with these. We write this as 2x plus 3, 2x take 3, and this one we can write as x plus 1 and x take 1. And then we have written it as the product of 4 linear factors. These are linear factors because each x term is to the power of 1. That's what a linear factor is. There's no squares or cubes or anything like that. Okay, so that was finishing off on that chapter on factorizing. I didn't quite get through all of chapter 1 like I was hoping, but hopefully I'll finish that off at maybe on Thursday. Tomorrow, we've already said, is A level, and we're going to be talking about proof and numerical methods. So we're going to change it up a little bit tomorrow. Right now, I'll throw it over to you. If you have any questions that you want to go through, we can talk about those. And yeah, we can go through any questions that you might have. So I'll just open it up. Whoops, I need to change my settings a little bit. I'll open it up to questions. Oops. Mathematics related. So I'll be here for about another 10 minutes or longer if there's any interesting questions that we can tackle. Always love to get new and interesting questions. John Doe says, hello, welcome. Are you good at maths? Not really. I don't think particularly good at maths. But I like it, you know. It's enjoyable for me. What is Baba plus Tunde? Right, don't know. Does the logarithms and exponentials topic link with your two pure differential equations? Logarithms and exponentials. Well, yeah, I mean, you're going to have differential equations with exponentials and logarithms. Babatunde. Ah, I see. Wow. Something to do with KSI? Alright. I'll have to check that out. So I guess we could have a quick look at logarithms and exponentials. So where was that? exponentials and logarithms. I mean, yeah, it already gets into it in AS level stuff. So we're already talking about the derivative of E and all of that kind of stuff. So yeah, definitely linked. And the natural log, of course, the integral and that kind of thing. It's my birthday today. Can you say my name 10 times? Oh, happy birthday, John Doe, 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 John Doe. There you go. 10 times. I should specify. Math related questions. I'm not saying that name. I'm not saying that name. But it's nice to meet you, Mr. Hunt. The entirety of Year 12 content. Well, my aim is to get through this entire textbook by the end of the summer in these live streams. I'm not sure how long that's going to take. Today we got through half of chapter 1. So let's say, and that took me about, well, how long have I been streaming? So about an hour and a half. It took me half of a chapter. So 14 chapters. So let's say it's 3 hours per chapter of hard work. 14 times 3, 42. So 42 hours. So it depends how much work you do per day. If you do an hour a day, 42 days. 6 weeks. If you do 2 hours a day, 21 days, 3 weeks. Of course, some work will take longer than others because this was just revision. So if you get to more difficult topics, maybe they take longer. Although, okay, and for example, the chapter on differentiation, there's 11 parts to it. So that's obviously going to take a lot longer than what we're working through at the moment. But yeah, I guess it just depends on your work rate, how much time you spend each day doing it. Maybe, okay, let's say an hour a day, and round that 42 hours up to maybe 60 hours. So 60 days. If you do that 5 days a week, that's 12 weeks. 60 divided by 5. Took me a minute. Do I work for Edexcel? No. That would be nice. I'd like to work for Edexcel. But no, I don't work for Edexcel. I just, I find well, I've taught Edexcel, so that's what I'm used to, basically. But yeah, so JT, hopefully that answered your question or gave you a rough estimate. John Doe has another question. Cool, no problem. Alright. If there are no other math related questions, then I think I'll end it there. Right tree says schedule. Okay, so I meant to start today at 11 a.m. So that's the plan for tomorrow, starting at 11 a.m. We'll see how we go. Obviously, things always don't go to plan, but that's the idea, to start at 11 a.m. daily. Actually, you know what? I feel like doing. I feel like playing some chess. Alright. So, I so far have played 2 games of chess, and I've won both of them. So, and I've been playing 10-minute games. And I've been watching a bit of chess. Actually, I haven't watched it for a few days now, but I've been picking a few things up. So let's see how we go with another 10-minute game today. Okay, so I'm playing the black pieces. And with any chess game, what you want to do is control the middle of the board. Now, usually I play this move because it goes right into the middle. But actually, I've been watching a few players and they play this move here. And what it does is you don't go straight into the middle, but you still control the center with this move like this. Past this move, I don't know what to play, but we will see how we go. Now, I believe I take that. Yes, because if I don't take it, he wins. Kabalan says, Magnus Carlsen, that is the world champion of chess, I believe. No, definitely not Magnus Carlsen. Okay. Any chess players? Feel free to give me tips. Feel free to tell me what to move. Is that cheating? I don't know. Raza, welcome. This is the end of a live stream, so I've finished going through the maths, and I just thought I'd play a quick game of chess to finish off. If you want to tune in tomorrow, there'll be more maths stuff. But for now, just finishing this one with a game of chess. I used to play when I was younger. Magnus beat 3 people while blindfolded at chess. Right. How do you even play blindfold? How do you play a game blindfold? Oh, you don't have to go. You can if you're a chess player, feel free to give me some tips. If you're not a chess player, then yeah, you can go. Just joking. Alright, so from what I know, I think bishops are better than knights. So if I take this bishop, then that's good for me, I think. Alright. Abdallah is in the chat. He can answer any maths related questions. Also, he has a YouTube channel that you can check out. Okay. So this rating I have is after playing 2 games. I think this is much too high for me because I don't actually know how to play chess. And I'm playing someone that clearly does know how to play. So I'm probably going to lose this game. Each square is a coordinate and he memorized each piece was and moved accordingly. Right. Yeah, so yeah, it's kind of mathematical, right? Coordinates and all that kind of thing. Ooh. Let's see if I can still. All right. This could be my first loss on this account. By the way, if you are ever on this site, it's lichess.org. Feel free to challenge me. My username is maths_explained. I do this move? I think so. You can take it though. Hey, this is not too bad. I haven't lost any material yet. Not too bad at all. Oh, Hams, George, thank you very much. Always appreciate a bit of flattery. I used to play quite a bit when I was younger. Haven't played for quite a few years. To play a bit faster because I'm losing on the clock. I don't know. Uh-oh. That was a bad move. Oh, no. Oh well, I'm way overrated anyway, so that's fine. dear. Maybe I can still win somehow. But I'm not sure. Oh no, I just lost a piece. Oh dear. Oh dear. This one's lost. This one's lost. Oh no. Is there any way to get out of checkmate? I don't think so. Try here, but then he goes here with a queen. Stalemate. I think I'm going to resign. Yeah, that's good game. What? I thought that was resign. Is this one resign? No, that's draw. This was resign. Oh, I have to click it again. Alright. Let's see. Okay. So this is the analysis. It tells you this number tells you who's winning. So plus means white's winning, negative means black's winning. Oops. So you can kind of get an idea of what's a good move and what's a bad move. At the moment, plus 0.2 is pretty much equal. Well, it's 0, 0 now, so it's saying it's equal. So I'm not doing too badly here. Okay, still not doing too badly. You can see the number is pretty close to 0. If it gets to 1 or negative 1, that means one of them is probably winning. Yana, hello, welcome. Oh, the lesson's over for today. I was just finishing the live stream with some chess. So apologies if you're expecting some more maths. I was just finishing the live stream off. Tomorrow, if you want to join in, there'll be more maths with tomorrow's live stream. So yeah, the reason I'm playing chess is because I've been watching a lot of other people play chess recently, and I thought it looked really fun. So, oh my god, did I miss a free piece? I missed a free piece. That's a free knight. Oh wow. That would have been completely winning. I missed a free piece. Pathetic. Ugh. Okay, so... Alright, so I'm still not doing too badly. Where did I lose? That's the question. Oh, this was a bad move. For some reason. This was a bad move. I don't know why. Oh, so... Okay, so look at this. So if I move my knight here... He can't move his knight here. Okay, so apparently this is a really good move for white, to have his knight here. I'm not sure why, but there you go. So if I'd moved my knight differently, that would have been better. And this is a really bad move for some reason. Oh, because he could have taken it. Oof. Yeah, and then this is what you call a fork, because he's attacking two of my pieces with the knight, and that was pretty much losing from there. Okay, so I think if I boil this game down, it's taking a free piece when your opponent blunders like that. Alrighty, okay. That's it. I was meant to end about 20 minutes ago. Thanks for joining in. I'll see you again tomorrow. The plan is 11 AM, but might be a bit later than that. Anyways, really fun as always. I'll see you tomorrow. Bye for now.